Hello everyone, this is Saurabh from Edureka, and in today's session we'll focus on big data. I have Reshma who will also be sharing her knowledge about big data with us. Welcome Reshma.
Hi Saurav and hello everyone. I hope you'll all find this session interesting and informative.
Even I hope so. So let's move forward and have a look at the agenda.
So this is what we'll be discussing today. We'll begin by understanding how data evolved, that is how big data came into existence. Then we'll see what exactly is big data. We'll understand what sort of data can be considered as big data. After that, we'll see how big data can be an opportunity. Now, obviously, big data is an opportunity, but we know that there are no free lunches in life. So we'll focus on the various problems associated in encasing this opportunity. And it won't be fair if I tell you only about the problems and not the solution. Therefore, we'll see how Hadoop solved these problems. And we'll dig a bit deep and understand about a few components of this Hadoop framework. And finally, we'll tell you about the big data and Hadoop training provided by Edureka. We'll also see the various projects that will be a part of this course. Now I feel, Saurav, it's the best time to tell the story about how data evolved and how big data came.
Fine Reshma, so we'll move forward.
So Saurav, what can you notice here?
Reshma, I see how technology has evolved. Earlier we had landline phones, but now we have smartphones. We have Android, we have iOS that are making our lives smarter as well as our phones smarter. Apart from that, we were also using bulky desktops for processing MBs of data. Now if you can remember, we were using floppies and you know how much data it can store, right? Then came hard disks for storing TBs of data, and now we can store data on cloud as well.
And similarly nowadays, even self-driving cars have come up. I know you must be thinking, why are we telling that? Now, if you notice, due to this enhancement of technology, we're generating a lot of data. So let's take the example of your phones. Have you ever noticed how much data is generated due to your fancy smartphones? Your every action, even one video that is sent through WhatsApp or any other messenger app, that generates data. Now this is just an example. You have no idea how much data you're generating because of every action you do. Now the deal is, this data is not in a format that our relational database can handle. And apart from that, even the volume of data has also increased exponentially. Now, I was talking about self-driving cars. So basically, these cars have sensors that records every minute details like the size of the obstacle, the distance from the obstacle, and many more. And then it decides how to react. Now, you can imagine how much data is generated for each kilometer that you drive on that car.
I completely agree with you, Reshma. So let's move forward and focus on various other factors behind the evolution of data. I think you guys must have heard about IoT. If you can recall in the previous slide, we were discussing about self-driving cars. It is nothing but an example of IoT. Let me tell you what exactly it is. IoT connects your physical device with internet and makes the device smarter. So nowadays, if you have noticed, we have smart ACs, TVs, etc. So we'll take the example of smart air conditioners. So this device actually monitors your body temperature and the outside temperature and accordingly decides what should be the temperature of the room. Now in order to do this, it has to first accumulate data. From where? It can accumulate data from internet, through sensors that are monitoring your body temperature and the surroundings. So basically from various sources that you might not even know about, it is actually fetching that data and accordingly it decides what should be the temperature of your room. Now we can actually see that because of IoT we are generating a huge amount of data. Now there is one stat also that is there in front of your screen. So if you notice, by 2020 we'll have 50 billion IoT devices. So I don't think so I need to explain much that how IoT is generating huge amount of data. So we'll move forward and focus on one more factor, that is social media. Now when we talk about social media, I think Reshma can explain this better, right Reshma?
Yeah, Saurabh, but I'm pretty sure that even you use it. So let me tell you that social media is actually one of the most important factor in the evolution of big data. So nowadays everyone is using Facebook, Instagram, YouTube, and a lot of other social media websites. So these social media sites have so much data. For example, it will have your personal details like your name, age, and apart from that, even each picture that you like or react to also generates data. And even the Facebook pages that you go around liking, that is also generating data. And nowadays you can see that most people are sharing videos on Facebook. So that is also generating a huge amount of data. And the most challenging part here is that the data is not present in a structured manner. And at the same time, it is huge in size. Isn't that right, Saurabh?
Can't agree more. The point you made about the form of data is actually one of the biggest factor for the evolution of big data. So due to all these reasons that we have discussed, have not only increased the amount of data, but it has also shown us that data is actually getting generated in various formats. For example, data is generated with videos, that is actually unstructured. Same goes for images as well. So there are numerous, or you could say millions of ways in which data is getting generated nowadays.
Absolutely. And these are just few examples that we have given you. There are many other driving factors for the evolution of data.
So these are few more examples because of which data is evolving and converting to big data. We'll discuss about the retail part. I'm pretty sure that all of you must have visited websites like Amazon, Flipkart, etc. And Reshma, I know you visited a lot of times.
Yeah, I do.
And suppose Reshma wants to buy shoes. So she won't just directly go buy shoes. She'll search for a lot of shoes. So somewhere her search history will be stored. And I know for sure that this won't be the first time that she's buying something. So there will be her purchase history as well, along with her personal details. And there are numerous ways in which she might not even know that she's generating data. And obviously Amazon was not present earlier. So at that time, there is no way that such huge amount of data was generated. Similarly, the data has evolved due to other reasons as well, like banking and finance, media and entertainment, etc., etc. So now the deal is, what exactly is big data? How do we consider a data as big data? So let's move forward and understand what exactly it is.
Okay, now let us look at the proper definition of big data, even though we've put forward our own definitions already. So Saurabh, why don't you take us through it?
Yes, Reshma, sure. So big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database system tools or traditional data processing applications.
Okay, so what I understand from this is that our traditional systems are a problem because they're too old-fashioned to process this data or something?
No, Reshma. The real problem is there is too much data to process. When the traditional systems were invented in the beginning, we never anticipated that we would have to deal with such enormous amount of the data. It's like a disease infected on you. You don't change your body orientation when you get infected with a disease, right, Reshma? You cure it with medicines.
Couldn't agree more, Saurabh.
Now the question is, how do we consider some data as big data? How do we classify some data as big data? How do we know which kind of data is going to be hard for us to process?
Well, Saurabh, we have the 5 V's to tell us that. So let's take a closer look at what are those. So starting with the first V, it's the volume of data. It's tremendously large. So if you look at the stats here, you can see the volume of data is rising exponentially. So now we're dealing with just 4.4 zettabytes of data, and by 2020, just in 3 years, it is expected that the data will rise up to 44 zettabytes, which is like equal to 44 trillion gigabytes. So that's really, really huge.
It is because all this humongous data is coming from multiple sources, and that is the second V, which is nothing but variety. We deal with so many different kinds of files at all once. There are MP3 files, videos, JSON, CSV, TSV, and many more. Now these are all structured, unstructured, and semi-structured altogether. Now let me explain you this with the diagram that is there on your screen. So over here we have audio, we have video files, we have PNG files, we have JSON, log files, emails, various formats of data. Now this data is classified into 3 forms. One is structured format. Now in structured format you have a proper schema for your data. So you know what all columns will be there, and basically you know the schema about your data. So it is structured, it is in a structured format, or you can say in a tabular format. Now when we talk about semi-structured files, these are nothing but JSON, XML and CSV files where schema is not defined properly. Now when I go to unstructured format, we have log files here, audio files, videos and images. So these are all considered as unstructured files.
And Saurabh, it is also because of the speed of accumulation of all this variety of data altogether, which brings us to our third V, which is velocity. So if you look here, earlier we were using mainframe systems, huge computers but less data, because there were less people working with computers at that time. But as computers evolved and we came to the client-server model, the time came for the web applications and the internet boomed. And as it grew among the masses, the web applications got increased over the internet. And everyone started using all these applications, and not only from their computers and also from mobile devices. So more users, more appliances, more apps, and hence a lot of data.
And when you talk about people generating data over internet, Reshma, the one kind of application that strikes first in my mind is social media. So you tell me how much data you generate alone with your Instagram posts and stories.
It will be quite a boast if I only talk about myself here. So let's talk including every social media user. So if you see the stats in front of your screen, you can see that for every 60 seconds, there are 100,000 tweets, actually more than 100,000 tweets generated in Twitter every minute. Similarly, there are 695,000 status updates on Facebook. When you talk about messaging, there are 11 million messages generated every minute. And similarly, there are 698,445 Google searches, 168 million emails, and that equals to almost 1,820 terabytes of data. And obviously the number of mobile users are also increasing every minute, and there are 217 plus new mobile users every 60 seconds.
Geez, that's a lot of data. I don't even want to go ahead and calculate the total. It would actually scare me.
Yeah, that's a lot. Now the bigger problem is how to extract the useful data from here.
And that's when we come to our next V, that is value. So over here what happens, first you need to mine the useful content from your data. Basically you need to make sure that you have only useful fields in your data set. After that you perform certain analytics, or you say you perform certain analysis on that data that you have cleaned. And you need to make sure that whatever analysis you have done, it is of some value. That is, it will help you in your business to grow. It can basically find out certain insights which were not possible earlier. So you need to make sure that whatever big data that has been generated or whatever data that has been generated, it makes sense. It will actually help your business to grow and it has some value to it. Now getting the value out of this data is one big challenge. Let me tell you why. And that brings us to our next V, which is veracity. Now this big data has a lot of inconsistencies. Obviously, when you're dumping such huge amount of data, some data packets are bound to lose in the process. Now what we need to do, we need to fill up these missing data and then start mining again and then process it and then come up with a good insight if possible. So if you can notice, there's a diagram in front of your screen. So over here we have this field which is not defined, similarly this field, and if you can notice here, when we talk about this minimum value, you see the other minimum values, and when you talk about this, it is way more than the other fields present in this particular column. Similarly goes for this particular element as well.
Okay, so obviously processing data like this is one problematic thing, and now I get it why big data is a problem statement.
Well, we have only 5 V's now, but maybe later on we'll have more. So there are good chances that big data might be even more big.
Okay, so there are a lot of problems in dealing with big data, but there are always different ways to look at something. So let us get some positivity in the environment now, and let us understand how can we use big data as an opportunity.
Yes, Reshma, and I would say the situation is similar to the proverb, when life throws you lemons, make lemonade.
Yeah, so let us go through the fields where we can use big data as a boon. And there are certain unknown problems solved only because we started dealing with big data.
And the boon that you're talking about, Reshma, is big data analytics. First thing with big data, we figured out how to store our data cost effectively. We were spending too much money on storage before. Until big data came into the picture, we never thought of using commodity hardware to store and manage our data, which is both reliable and feasible as compared to the costly servers. Now let me give you a few examples in order to show you how important big data analytics is nowadays. So when you go to a website like Amazon or YouTube or Pandora, Netflix, any other website, so they'll actually provide you certain fields in which they'll recommend some products or some videos or some movies or some songs for you, right? So how do you think they do that? So basically whatever data that you are generating on these kind of websites, they make sure that they analyze it properly. And let me tell you guys, that data is not small. It is actually big data. Now they analyze that big data and they make sure that whatever you like or whatever your preferences are, accordingly they'll generate recommendations for you. And when I go to YouTube, I don't know if you guys must have noticed it, but I'm pretty sure you must have done that. So when I go to YouTube, YouTube knows what song or what video that I want to watch next. Similarly, Netflix knows what kind of movies I like. And when I go to Amazon, it actually shows me what all products that I would prefer to buy, right? So how do you think it happens? It happens only because of big data analytics.
Okay, so there is one more example that just popped into my mind I'll share with you guys. So there was this time when the Hurricane Sandy was about to hit on New Jersey in the United States. So what happened then? The Walmart used big data analytics to profit from it. Now I'll tell you how they did it. So what Walmart did is that they studied the purchase patterns of different customers when a hurricane is about to strike or any kind of natural calamity is about to strike on a particular area. And when they made an analysis of it, so they found out that people tend to buy emergency stuff like flashlight, life jackets, and a little bit of other stuff. And interestingly, people also buy a lot of strawberry Pop-Tart.
Strawberry Pop-Tarts? Are you serious?
Yeah. Now, I didn't do that analysis, so Walmart did that, and apparently it is true. So what they did is they stuffed all their stores with a lot of strawberry Pop-Tarts and emergency stuff, and obviously it was sold out and they earned a lot of money during that time.
But my question here, Reshma, is people want to die eating strawberry Pop-Tarts? Like, what was the idea behind strawberry Pop-Tarts? I'm pretty unsure about it. But yeah, since you have given us a very interesting example and Walmart did that analysis, we didn't do it. So yeah, so it is a very good example in order to understand how big data analytics can help your business to grow and find better insights from the data that you have.
Yeah, and also if you want to know why strawberry Pop-Tarts, maybe later on we can start making an analysis by gathering some more data also.
Yeah, that can be possible.
Okay, so now let's move ahead and take a look at a case study by IBM, how they have used big data analytics to profit their company.
So if you have noticed that earlier the data that was collected from the meters that you have in your home that measures the electricity consumed, it is actually sending data after 1 month. But nowadays what IBM did, they came up with this thing called smart meter, and that smart meter used to collect data after every 15 minutes. So whatever energy that you have consumed after every 15 minutes, it will send that data. And because of it, big data was generated. So we have some stats here which says that we have 96 million reads per day for every million meters, which is pretty huge. This data, the amount of data that is generated is pretty huge. Now IBM actually realized the data that they're generating, it is very important for them to gain something from that data. So for that what they need to do, they need to make sure that they analyze this data. So they realize that big data analytics can solve a lot of problems and they can get better business insight through that. So let us move forward and see what type of analysis they did on that data. So before analyzing that data, they came to know that energy utilization and billing was only increasing. Now after analyzing big data, they came to know that during peak load, the users require more energy, and during off-peak times, the users require less energy. So what advantage they must have got from this analysis? One thing that I can think of right now is they can tell the industries to use their machinery only during the off-peak times, so that the load will be pretty much balanced. And you can even say that time of use pricing encourages cost-savvy retail like industrial heavy machines to be used off-peak time. So yeah, they can save money as well because off-peak times pricing will be less than the peak time prices, right? So this is just one analysis. Now let us move forward and see the IBM suite that they developed. So over here, what happens? You first dump all your data that you get in this data warehouse. After that, it is very important to make sure that your user data is secure. Then what happens? You need to clean that data. As I've told you earlier as well, there might be many fields that you don't require. So you need to make sure that you have only useful material or useful data in your data set. And then you perform certain analysis.
And in order to use this suite that IBM offered you efficiently, you have to take care of a few things. The first thing is that you have to be able to manage the smart meter data. Now there is a lot of data coming from all this million smart meters. So you have to be able to manage that large volume of data and also be able to retain it because maybe later on you might need it for some kind of regulatory requirements or something. And the next thing you should keep in mind is to monitor the distribution grid so that you can improve and optimize the overall grid reliability so that you can identify the abnormal conditions which are causing any kind of problem. And then you also have to take care of optimizing the unit commitment. So by optimizing the unit commitment, the companies can satisfy their customers even more. They can reduce the power outages so that their customers don't get angry more, identify problems, and then reduce it, obviously. And then you have also to optimize the energy trading. So it means that you can advise your customers when they should use their appliances in order to maintain that balance in the power load. And then you also have to forecast and schedule loads. So companies must be able to predict when they can profitably sell the excess power and when they need to hedge the supply. And continuing from this, now let's talk about how Oncor have made use of the IBM solution. So Oncor is an electric delivery company, and it is the largest electrical distribution and transmission company in Texas. And it is one of the 6 largest in the United States. They have more than 3 million customers, and their service area covers almost 117,000 square miles. And they began the advanced meter program in 2008, and they have deployed almost 3.25 million meters serving customers of North and Central Texas. So when they were implementing it, they kept 3 things in mind. The first thing was that it should be instrumented. So this solution utilizes the smart electricity meters so that they can accurately measure the electricity usage of a household in every 15 minutes, because like we discussed that the smart meters were sending out data every 15 minutes, and it provided data inputs that is essential for consumption insights. Next thing is that it should be interconnected. So now the customers have access to the detailed information about the electricity they are consuming, and it creates a very enterprise-wide view of all the meter assets, and it helps them to improve the service delivery. The next thing is to make your customers intelligent. Now, since it is getting monitored already about how each of the household or each customer is consuming the power, so now they're able to advise the customers about maybe to tell them to wash their clothes at night because they're using a lot of appliances during the daytime, so maybe they could divide it up so that they can use some appliances at off-peak hours so that they can even save more money. And this is beneficial for both of them, for both the customers and the company as well. And they have gained a lot of benefits by using the IBM solution. So what are the benefits they got is that it enabled Oncor to identify and fix outages before the customers get inconvenienced. It means they were able to identify the problem before it even occurred. And it also improved the emergency response on events of severe weather events and views of outages. And it also provides the customers the data needed to become an active participant in the power consumption management. And it enabled every individual household to reduce their electrical consumption by almost 5 to 10%. And this is how Oncor used the IBM solution and made huge benefits out of it just by using big data analytics that IBM performed.
But let me just interrupt right now. So since Reshma told us in the beginning as well that there are no free lunches in life, right? So this is an opportunity. But there are many problems to encase this opportunity, right? So let us focus on those problems one by one. So the first problem is storing colossal amount of data. So let's discuss few stats that are there in front of your screen. So data generated in past 2 years is more than the previous history in total. So guys, what are we doing? Stop generating so much amount of data. And it is said that by 2020, total digital data will grow to 44 zettabytes approximately. And there's one more stat that amazes me is about 1.7 MB of new information will be created every second for every person by 2020. So storing this huge data in traditional system is not possible. The reason is obvious. The storage will be limited for one system. For example, you have a server with a storage limit of 10 terabytes, but your company is growing really fast and data is exponentially increasing. Now what you'll do? Now at one point you'll exhaust all the storage. So investing in huge servers is definitely not a cost-effective solution. So Reshma, what do you think what can be the solution to this problem?
According to me, a distributed file system will be a better way to store this huge data, because with this we'll be saving a lot of money. Let me tell you how. Because due to this distributed system, you can actually store your data in commodity hardware instead of spending money on high-end servers. Don't you agree, Saurabh?
Completely. Now we know storing is a problem, but let me tell you guys, it is just one part of the problem. Let's see a few more.
Okay, so since we saw that the data is not only huge, but it is present in various formats as well, like unstructured, semi-structured, and structured. So you not only need to store this huge data, but you also need to make sure that a system is present to store this varieties of data generated from various sources. And now let's focus on the next problem.
Now let's focus on the diagram. So over here you can notice that the hard disk capacity is increasing, but the disk transfer performance or speed is not increasing at that rate. Let me explain you this with an example. If you have only 100 Mbps input output channel and you are processing say 1 terabytes of data. Now how much time will it take? Maybe calculate, it'll be somewhere around 2.91 hours, right? So it'll be somewhere around 2.91 hours. And I've taken an example of 1 terabytes. What if you're processing some zettabytes of data? So you can imagine how much time will it take. Now what if you have 4 input output channels for the same amount of data? Then it'll take approximately 0.72 hours, or converted to minutes, so it'll be around 43 minutes approximately, right? And now imagine instead of 1 TB you have zettabytes of data. For me, more than storage, accessing and processing speed for huge data is a bigger problem. Okay, so Reshma has a very good example to discuss.
Yeah, so since you were talking about accessing the data and you told us already about how Amazon, different websites and YouTube, they make those recommendations. So if there was no solution for it, if it would take so much time to access the data, the recommendation system wouldn't work at all. And they make a lot of money just by recommendation system because a lot of people go there and click over there and buy that product, right? So let's consider that it is taking like hours or maybe years of time in order to process that big amount of data. So let's say that at one time I purchased an iPhone 5S from Amazon, and after 2 years, I'm again browsing onto Amazon, and since it took so much time to access the data and I've already switched over to a new iPhone and they are recommending me the old iPhone case for 5S. So obviously that won't work. I won't go there and click it because I've already changed my phone, right? So that will be a huge problem for Amazon. The recommendation system won't work anymore.
And I know that Reshma changes her phone every year. So if she has bought a phone and people are recommending, if she has bought a phone now and someone's recommending the case for that phone after 2 years, doesn't make sense to me at all.
Yeah, only it'll work if I have both the two phones at the same time. But yeah, I don't want to waste money on purchasing new iPhone case for my older phone.
So basically, it won't be fair if we don't discuss the solution to these problems. Reshma, we can't leave our viewers with just the problems, right? It won't be fair. What is the solution? Hadoop. Hadoop is a solution. So let's introduce Hadoop now.
Okay, so now what is Hadoop? So Hadoop is a framework that allows you to first store big data in a distributed environment so that you can process it parallelly.
There are basically two parts. One is HDFS, that is Hadoop Distributed File System for storage. It allows you to store data of various formats across a cluster. And the second part is Mapreduce. Now it is nothing but a processing unit of Hadoop. It allows parallel processing of data that is stored across the HDFS. Now let us dig deep in HDFS and understand it better.
Yeah, so HDFS creates an abstraction of resources. Let me simplify it for you. So similar to virtualization, you can see HDFS logically as a single unit for storing big data. But actually you're storing your data across multiple systems, or you can say in a distributed fashion. So here you have a master-slave architecture in which the name node is a master node and the data nodes are slaves. And the name node contains the metadata about the data that is stored in the data nodes, like which data block is stored in which data node, where are the replications of the data block kept, and etc., etc. So the actual data is stored in the data nodes. And I also want to add that we actually replicate the data blocks that is present in the data nodes. And by default, the replication factor is 3. So it means that there are 3 copies of each file. So Saurav, can you tell us why do we need that replication?
Sure, Reshma. Since we are using commodity hardwares, right, and we know failure rate of these hardwares are pretty high. So if one of the data nodes fail, I won't have that data block. And that's the reason we need to replicate the data block. Now this replication factor depends on your requirements, right? Now let us understand how actually Hadoop provided the solution to the big data problems that we have discussed. So Reshma, can you remember what was the first problem?
Yeah, it was storing the big data. So how HDFS solved it, let's discuss it. So HDFS provides a distributed way to store big data. We've already told you that. So your data is stored in blocks, in data nodes, and you then specify the size of each block. So basically, if you have a 512 MB of data and you have configured HDFS such that it will create 128 megabytes of data block. So HDFS will divide the data in 4 blocks because 512 divided by 128 is 4. And it will store it across different data nodes, and it will also replicate the data blocks on the different data nodes. So now we are using commodity hardware and storing is not a challenge. So what are your thoughts on it, Saurabh?
I will also add one thing, Reshma. It also solves the scaling problem. It focuses on horizontal scaling instead of vertical. Now you can always add some extra data nodes to your HDFS cluster as and when required instead of scaling the resources of your data nodes. So you're not actually increasing the resources of your data nodes, you're just adding few more data nodes when you require. Let me summarize it for you. So basically for storing 1 TB of data, I don't need a 1 TB system. I can instead do it on multiple 128 GB systems or even less. Now Reshma, what was the second challenge with big data?
So the next problem was storing variety of data. And that problem was also addressed by HDFS. So with HDFS, you can store all kinds of data, whether it's structured, semi-structured, or unstructured. It is because in HDFS, there is no pre-dumping schema validation. So you can just dump all the kinds of data that you have in one place. And it also follows a write once and read many model. And due to this, you can just write the data once and you can read it multiple times for finding out insights. And if you can recall, the third challenge was accessing the data faster. And this is one of the major challenges with big data. And in order to solve it, we're moving processing to data and not data to processing. So what it means, Saurabh, just go ahead and explain it.
Yes, Reshma, I will. So over here, let me explain you what you mean by actually moving process to data. So consider this as our master and these are our slaves. So the data is stored in these slaves. So what happens, one way of processing this data is, what I can do is I can send this data to my master node and I can process it over here. But what will happen if all of my slaves will send the data to my master node? It will cause network congestion plus input-output channel congestion, and at the same time, my master node will take a lot of time in order to process this huge amount of data. So what I can do, I can send this process to data. That means I can send the logic to all these slaves which actually contain the data and perform processing in the slaves itself. So after that, what will happen, the small chunks of the result that will come out will be sent to our name node. So in that way, there won't be any network congestion or input-output congestion, and it will take comparatively very less time. So this is what actually means sending process to data. So I hope you all are clear with this. I hope even Reshma is clear.
I'm clear.
All right, good to hear that. So let's move forward and focus on few components of Hadoop. So we'll look at the Hadoop ecosystem.
So you can see that this is the entire Hadoop ecosystem. So there are a lot of tools that we use. So there you can see that we have Flume and Scoop, and they're used to ingest data into HDFS. Now we've already seen what HDFS is. So there's one more component which is known as Yarn. And you can consider Yarn as the brain of your Hadoop ecosystem. It performs all your processing activities and it allocates resources and schedules different tasks.
Now, apart from these components, there are many other components as well. So I'll just give you a brief introduction about these components. We have Pig and Hive, which are nothing but the analytics tool. Hive was introduced by Facebook and Pig was introduced by Yahoo. Now, the language that is used here is called Pig Latin. And over here, we use Hive query language, which is very similar to SQL. The story behind Hive is very, very interesting. I want to share this. So basically, Facebook wanted some tool in order to perform queries on the huge chunks of data. So what they did, they introduced Hive. So with the help of Hive, they can actually use the same employees which know SQL and they can perform analytics on a huge set of data, that is big data. Apart from that, we have Spark as well, which is used for near real-time processing. And in order to perform machine learning, we have a component in Spark itself that is called MLlib and even Mahout. Now, when we talk about Mapreduce, we all know what exactly Mapreduce is. It is basically Java programs only that are used to process your big data. Now when I talk about Apache HBase, now HDFS is a file system. And what is HBase? HBase is nothing but a NoSQL database on top of HDFS. Now let's move forward and focus on few important components among these. Now Hadoop, we all know what exactly Hadoop is. What is Hive? Apache Hive is nothing but a data warehousing tool that allows you to perform big data analytics using Hive query, and this language is very similar to SQL, and I've told you the story also behind it, why Facebook actually implemented it. Now when we talk about Apache Pig, it is again an analytics tool which is used to analyze large set of data, representing them as data flows. Spark is nothing but in-memory data processing engine that allows us to efficiently execute streaming, machine learning, SQL workloads, and requires fast iterative access to data sets. So basically streaming and all those things in which you require near real-time processing, you can integrate Spark with Hadoop. What is HBase? It is nothing but a NoSQL database present on top of your HDFS file system. So this is all about Hadoop and big data. Now the point is how Edureka can help you become a big data and Hadoop expert. Now let's move forward and understand the big data and Hadoop training provided by Edureka. Big Data Hadoop certification training. So Edureka provides a structured program in order to make you a certified Hadoop developer. Now before I explain you the structure of the program, let me tell you guys that Edureka provides 24/7 support team. So if you have any questions or doubts at any point of time, you can contact them. Apart from that, wherever you pay for the course, you get access to LMS. Now what is LMS? LMS is nothing but learning management system. So all of your class recordings, your PDFs, your presentations will be there in your LMS, and you get the access to LMS for lifetime. Let me tell you, you get it for lifetime. So once you're even done with the course and you want to take it again, you can do that as well. So you come back after 10 years also and you want to learn Hadoop, we will put you in a live batch. So basically you get everything for lifetime. So let's focus on the structure of the program. So it starts with basics and it covers all the advanced portion of Big Data Hadoop as well. So in the first module, you'll be learning about what exactly Big Data and Hadoop is and various concepts, just the introductory module. Then comes the concepts of HDF and Mapreduce, how does the architecture looks like and all those things. And then in the third module, you'll understand how to actually set up Hadoop cluster and how this architecture looks like. In the fourth module, you'll be dealing with Mapreduce program. Then in the fifth module, you'll learn data loading techniques. Then comes the sixth module. Now in sixth module, you'll be introduced to analytics tools like Pig and Hive. And I've told you earlier as well why we use Pig and Hive. Then comes HBase, which is nothing but a NoSQL database on top of HDFS. After that, we have 𝐓𝐫𝐞𝐻. Then we'll look at various best practices for Hadoop development. Now comes Spark. Now let me tell you, we won't discuss too much about Spark in this course. Edureka has a separate course on Spark, but still we have included the introduction of Spark in Big Data Hadoop as well. You'll also learn how to work in RDD in Spark. And finally, you'll be working on real life project on big data analytics. So once you're done with this project, on the basis of how you have done it, you'll be getting grades in your certificate. So you'll get the certificate only when you are done with the project. And we have multiple projects. So it's not like once you have done with one project, you cannot take up the other project. You can do that as well. You can take multiple projects. You can just request for multiple projects and definitely they'll give it to you. But at least one project you need to finish in order to get the certification. So we'll move forward. And Reshma will give you an introduction of what all projects are part of this course.
Yeah, so these are some of the projects that you can choose to work on. So the first one, you can see that it is to analyze social bookmarking sites. Now I'll tell you a little bit about that. So here you have to work with the social media data. So the data here will comprise of the information gathered from sites like reddit.com, stumbleupon.com, etc. So these are bookmarking sites and they allow you to bookmark, review, rate, and search various links on any kind of topic. So the data is in XML format and it contains various kind of links, posts, URLs, and different categories defining it, and the ratings are linked with it. So what you have to do is that you have to analyze the data in the Hadoop ecosystem so that you can fetch data into the HDFS and analyze it with the help of Mapreduce, Pig, and Hive to find out the top rated links based on user comments, likes, etc. So this is the problem statement. So you have to analyze the entire data, all the posts in this kind of sites, and you have to find the top post according to the likes and comments. So this is what you have to do. Similarly, we have other projects like the customer complaint analysis. So this is related to the retail industry. Similarly, you have tourism data analysis, which is related to some tourism data facts, and you have airline data analysis, the loan data set, which is related to banking and finance, movie ratings, which is the media data set. So you can choose any of the projects from it. So you can give it a try and come up with a solution for all these problems. And if any time you stumble upon something and you're stuck with something, we have our support team, which is 24/7 available. You can call us anytime and they will help you with that.
So Reshma, I was thinking, how about we give a brief summary of what all things we have discussed till now?
Yes, Saurav, that would be great. So we should just go ahead and provide with the summary.
So we started with how data evolved and how big data came into existence. We saw various factors that actually led to big data. Then we focused on 5 V's. So basically, in order to consider any data as big data, we need to consider these 5 V's. And what are those 5 V's, Reshma?
So first we saw the volume of data, then we saw variety, velocity, value, and finally veracity.
All right, fine. Then we focused on big data as an opportunity. We discussed quite a lot of examples, and I'm still unclear why people are buying strawberry Pop-Tarts during hurricanes. But that's not the point.
But don't worry, Saurav, we'll find out that answer for you.
All right. So after those examples, we saw a case study of IBM. Then we shifted our focus towards the problems that are associated with big data. Now, obviously, it is an opportunity, but in order to encase that opportunity, you need to come up with a solution to all these problems. And what was the solution, Reshma?
The solution was Hadoop. And we have seen how to use HDFS and Mapreduce in order to solve those problems. And finally, we discussed about the curriculum, the Hadoop curriculum in Edureka, the kind of projects that you can choose and what all you'll be learning in this course.
All right, fine. So by this, we come to the end of today's session. Thank you, Reshma, for joining us. It was a pleasure having you in today's discussion.
Thank you, Saurav. I enjoyed it a lot as well.
Thank you and have a great day.